Global Teleservice Limited, India during the year 2006. Sir worked as a junior project consultant, industrial engineering and management, sponsored research and industrial consultancy, IIT Kharagpur in 2007. Sir worked as a junior project assistant in GS Sanyal School of Telecommunications, sponsored research and industrial consultancy, IIT Kharagpur during 2007 to 2010. Sir worked as a senior lecturer in the Department of ENC at Faculty of Science and Technology, ICFEI University, Agartala, Tripura during the year 2010 to 2011. From 2010, from 2011 to till to date, the sir is working as a assistant professor in the Department of ENC at Birla Institute of Technology, Mesra. Sir research areas are medical imaging, machine learning, vital sign monitoring, e-health and m-health, wireless communication and telemedicine. Sir received a Global Peer Review Award in the year 2018. Sir received Young Faculty Award from Venus International Faculty Awards, VIFA, during the year 2018. Sir received Young Research Excellence Award from Cosmic ETM, Bangkok, Thailand during the year 2018. Sir received Best Paper of the Session Award in the Global Wireless Summit, South Africa during the year 2017. Professor also selected in Albert Nelson Moritz Lifetime Achievement Award during the year 2017 and also received the Outstanding Researcher Award from the Top Engineer Student and Faculty Awards during the year 2016. And sir received Best Paper of the Session Award in the International Conference of Recent Advances in Engineering and Technology from Hyderabad during the year 2012. Sir was invited as a guest speaker in various FDPs and HTTPs in IIT Patna and also in Tripura Institute of Technology and in NIT JIS University, Kolkata. Sir delivered many guest lectures and seminars in various institutes. Sir published more than 11 book chapters in reputed publishers like Elsewhere and Springer journals. Sir published more than 11 papers in reputed international journals. So we are very much lucky to have such an eminent personality as a resource person for this FDP. With this brief note, I conclude my introductory speech. Thank you, one and all. Now I request the Dr. Chinmay Chakravarti sir to start the session. Hello, sir.
Sir.
Yes, sir.
Okay, got connected?
Hello, sir.
Sir, Dr. Chinmay is there?
Yes, sir. Sir was there just now. They left that. I think I'm trying to connect in with them.
Please tell, sir.
Yes. I request all the participants to be online. Due to some technical issues, the sir left the meeting.
Hello.
Yes, yes, sir. Yes, sir.
Yeah, yeah. Network got cut. So if the
Yes.
network got cut, then you don't worry. I will rejoin you maybe 2 minutes.
Okay. So your voice is
Okay.
breaking. Hmm. Now,
Yeah. Go ahead, please.
yes, yes, sir. You can start, sir.
Okay, now I can start. Okay,
Yes,
fine.
yes, yes, sir.
So
Thank you.
sorry, as I missed the last few sentences because the network. Anyway, welcome all the participants to this webinar organized by your institute on advanced research trades in image processing. And thank you all the organizing members for inviting me to be part of your seminar. And I'm straight away going to basically to the lecture, which will be helpful because in webinar, managing time is difficult because of the network. There's a lot of aids. So let me present my screen. Okay. So is it visible? Hello, can you confirm me? Is it visible? Slide is visible. Hello. Hello. Nobody is responding. One of you respond, please. The convener should respond once I'm asking because
you can hear you.
Okay, so silence means you are able to hear me. That I will presume because we have to contact any. Okay. Okay. Thank you. Just to confirm me once again that my slide is visible to all of you or not. That's all. That is another thing. Just a second. Is it visible now?
Yes, sir. Yes, sir.
Yes. Okay. Without slide, we can't. Okay. Thanking you once again. Today's topic of the seminar is chronic wound image analysis. In this respect, you should know the current reality. Situation very difficult to imagine sitting at one place, but at least in the country you can look at different kind of situations. Every country population is the age is growing. The moment the age is growing, the different types of things usually affect the human population. In our country, we find different kinds of ulcers. For diabetic patient, it's a diabetic ulcer because I told aged population because when the age is increasing, then everybody is got an inflammation, and if that is ulcer, called diabetic ulcer, renal ulcer, pressure ulcer, malignant ulcer, pyoderma gangrenis. So different types of ulcers that affect the human population. But that are wounds. But what do you mean by chronic wounds? Chronic means some wounds in our human body on the skin, outer surface of the skin, from the outside, what you can visualize actually, doesn't cure in a very short time. That means that sustains for very longer duration. From medical point of view, there is a some kind of recommendation that any wound that sustains for more than 6 years, that is really treated as the chronic wound. Okay, wound is basically kind of an infection and inflammation that happens outside of the, also maybe inside of the body. But we are going to talk about the outside of the body, in the skin, what we can see from the outside. So there are varieties of wounds according to cutting from this paper. These are the wounds which are very much important and common in our population. So how it is dangerous? The wound is very much dangerous because when ulcer is there, ulcer may convert into cancer even, the transmission may also to cancer. That can't happen immediately, but not after a long time. There be a damage because ulcer starts means that person tissue has got some damage. Tissue has become dead. So once you have a dead cell inside of the body, then you have a live tissue and you have a dead tissue. Then there will be basically dead tissue will not take anything, will not give anything. It's dead. So live and dead tissue cannot stay. Right, like a human being, a dead body and we are living people cannot sit together. So that's what that becomes a foreign element, and when foreign element is present inside of the body, that hampers the human system. That's why it's very dangerous. And with cancer, we are always afraid of this kind of a term, kind of a cancer. So ulcer can also be transmitted to and converted to the cancer. Now the point is that globally, more than 35 billion people suffer. As per 6 people, maybe later it will be very, very high. Keep aside the COVID situation. First of all, I forgot to tell, but definitely everybody is staying safe and in your home or safe place, and all of you are well. That's what you are attending definitely. That is another way of drawing the information, Anyway, so, but from the in the Indian scenario, the prevalence rate, that means it's like that every out of 1,000 population, 4.48 people getting affected, which is not less actually, you should forget. Because maybe the cause of some other diseases, the severity is very low. It mostly affects the aged people, because when people having the diabetes, India is, according to WHO, India is the diabetes capital in the world. Which is that is sad to hear, but that you have to accept, because that is the reality. Now it is that report published in 2007 by WHO Organization, 20% of 25% are expected in 2020. So we are mostly we have crossed 25%. Now we are talking about 2030, while that rate is also increasing. So progressively, this increase silent epidemic and a major threat to the public. So I hope I am able to give you the importance of this study, importance of why this kind of topic should be considered with it's not much given. From the engineering point of view, can we provide some solution which can support in terms of controlling the system, in terms of monitoring the wound management system. So wound image analysis, basically the analyzing the photographs of the digital images of the wounds, and you're analyzing this analytically. You are analyzing. Obviously, qualitative analysis also there. That is scoring for everything, but quantitative means more precision. The image to be analyzed for understanding and characterization of different types of wounds and their progression rates over the different period of time. Somebody has got detected the wound. Dr. David gives treatment. The moment starting the treatment, that time it is assumed that over some time it will be curing. But sometimes it might not so happen. It's not curing, or other way it is increasing. So that way we become very much, disappointed and so that's what silent epidemic I'm calling. We can see how it is occurring. Different types of wounds are there, starting from surgical wounds to skin cancer. Surgical wounds basically it happens inside, but here it is taken from the Atlantis report, where it is shown. But we will talk about anything which visible from the outside. There are chronic lower extremity wounds. In the body, the lower extremity portions have different types of wounds. Some legs, some mostly are the leg based. In the knee area, the first one is between the knee and toe. Second one is knee area, the kind of thing. Third one is the foot area. So these images have been paired by a standard optical, Sony cyber camera, which is W5K. There are some open source database available to detect wound images. People have published in papers also, but we have we have mainly worked on a very simple normal camera, digital camera, of course. The first one is called vascular ulcer, second one is called pressure ulcer, and diabetic ulcer. Looking at things, we as a human can understand at least picture, color combination. Doctor also do exactly the same thing. They also look at the color combination, and depending on the color combination, they identify which ulcer of what. So you know, remember, number of doctors is less, number of patients is more. That is a bottleneck in our country. I'm not going to analyze other countries. I'm looking at my country. That patient doctor is like the way as a teacher we calculate student teacher ratio. If you calculate the patient doctor ratio, then our head will increase because we'll find our in comparison with the volume of the population. But population will be affected, then how to measure, how to control, then definitely you should have some mechanisms, screening device kind of thing, which take care of these things. And then if your ulcer is very dangerous, your ulcer is not that, we don't think about that. So this kind of recommendation, if you get immediately through a even smartphone apps kind of things, so definitely, definitely. So that is the idea behind this why it is required. So here's something you know, this takes complete sequence. You can see there are another, what I'm saying, there is a schematic images, 3 images. They are completely red. So any ulcer having complete red is granular. 3 different tissues are existing inside the wound area. Okay. So when you think the wound area is very much red, it's in nature, completely okay. So you see the very much the granulation, necrotic, and slab. Granulation is the terminology is basically the biological terminology, medical terminology. So these 3, one wound, what different tissues are there. Granulation is one type of gives the indication of blood circulation. Necrotic basically some of the dead tissue. So it looks like dead means mostly blackish. Slab means basically yellow type of thing. So every tissue has different role to play in terms of healing of wound. Okay. So traditional clinical impact. So we understood the importance of this study. We understood what are the different types of wounds are affecting the population, and with the wound, the different types of tissue. So that's medical side we have understood. Now the question comes that what is the
Excuse me, sir.
what? Hello.
Sorry for interrupting you, sir.
Yeah.
Sir, voice is in between breaking, sir, so that so many participants are asking us in the chat box.
What is that?
Voice is breaking, sir, in between.
Oh, voice is breaking. This is now it's okay.
Yes, sir.
Is it okay?
Yes, sir. Thank you.
Okay. Yeah, I can't see the chat box. So
Yes, sir.
I'm using the full screen. Okay.
Yes, sir. You can continue. Thank you.
Okay. So primary clinical parameters. Any patient has this wound, when we go, then what will do? We definitely the family person take the person to the clinic of the physician, first key dermatologist. So any medical expert. Medical expert once they observe in the that wound area. Basically, they are looking for 3 kind of colors, and the colors are not existing separately. Colors are existing coexisting. That means they are mixed, and that is non-uniform in nature. So yellow slab, black necrotic, red granulation. So yellow is the color and the tissue together. Okay. So These are the primary clinical parameters based on which the doctor visualize the wound, and they are going to take a decision. Because before treatment, diagnosis has to be done. If diagnosis is correct, then treatment is expected to be correct. If diagnosis is wrong, then definitely the treatment is going to be wrong. There are different methods which are in the emergency clinic, the medical hospitals, the rural-based method, transparency tracing methods, alginate casts. People conventionally use, and these are the different kinds of through which they are trying to understand the severity of the wound, area of the wound, depth of the wound, because you can't do ultrasound, CT, X-ray for this. You have to get it. This kind of image. You see here through pain they are identifying the boundary. It's a ruler pain. They are trying to find out what is the area. So algae or saliva they can see in a piece of transparent cloth is given, and then that is grids are there. Some kind of fluid is given. So when the fluid is surrounding the whole area, and then that particular color will be that area will be colorified, and that without the transfer you can normalize it. But everything is done manually. Here everything is done manually, and when you do something manually, that is most frequently that becomes inaccurate, and you can understand this is painful because anybody suffering from any ulcer, any kind of wound, that time itself some pain is there. At that time, if you externally apply something, whether injection or you are touching and cleaning, rubbing, then definitely that becomes much more painful, intolerable. Ambiguities are observed. So there are different kinds of disadvantages of doing these things, because from patient point of view it becomes much more painful and tolerable, but from the from our point of view, information is not accurate, because doctor to doctor relation every for all disease member, if you go to the two doctors, then they will write two different, if not completely different, but to some extent different should be there. Exactly same thing they will not write in the diagnostic. Is a trend to schedule. There are different techniques are there. I'm not going to tell you this. It's just for information I have to give. So contact mode, how it is done, non-contact mode. That is mostly digital imaging, stereo photography, mathematical models, simple. So 3D measurement also is required. Nowadays 3D printing has come, the technology based on which a wound can be modeled, and for the surgical purpose that gives sometimes a better things for implants and other issues. Now, for any study, you do to catch, you understand what are the limitations of that things, and that limitation will motivate you, to push it further. Otherwise, hello.
Excuse me, Dr. Chenmai. Hello.
Hello. I think what my suggestion, you can hear me. Let me finish my lecture. Then we will discuss. I will answer the question, technical questions.
Sound is taken.
In between drafts, I don't know, but only problem the network issue, audibility issue. So as long as you can hear me, it's better. Let me finish first, and at the end I will take your questions. Okay, you can note down in your notes. All right.
Sir, still voice is not so clear, sir. So please.
Okay, no, that request should be always should interrupt me. But I am in class on also no problem right now. Is it now? Is it now fine? Is it?
Yes, sir. It's not breaking now. Okay, sir. You can.
Okay. Now it's okay, right? Now it's okay, right?
Yes, sir. Yes, sir.
Limitations left you can see mostly depending on color information. That is the it's a mostly qualitative assessment. Doctor, whatever they look at through their eyes, they can write accordingly. When subjectivity is kind of person-specific decision, and that involves ambiguities. Ambiguities means the picture is not completely clear. No information about what percentage of tissue. They look at overall the tissue. But if I ask the question, the doctor, can you tell me that what is the percentage of tissue available within that sometimes they cannot tell, because that needs information. So togetherly, the area matters, because when area is small, that is easy to track and control. But when the area is spread, it becomes very difficult. And the larger the area means your with respect to the life, it is going to be dangerous. Obviously, like other disease, it is high expert, because more mature doctor is always accepted to do a better. Here, doctors might not have that much information. They provide the medical health facility to all people in rural places. You understand what is the scenario in the hospitals or what the doctors. Here, even the junior doctors are also not available. So to manage this kind of situations, you have to do something from engineering side. It is also true that in India, no community database has been developed, mostly, as far as I know. But probably privately people are developing, but in the open source things are not available. But with the government website, it is available. So I think when it is majorly hampering the country, the different states have, every states have higher education institutes and research facilities. They can take up this kind of this project to develop statewide own database. Database will give not only it, but also will help to find some cases. So these are the limitations based on which we attempt to assess the wound quantitatively, not only by color. Color is the issue. We can see, the human eyes can see the color, but texture we cannot understand. But a mathematical computer representation can be done to understand the texture of the feature. The way you are wearing some shirts, the shirts, every shirt has color. Then whether it's a, but how the texture of the shirt is, then we touch the shirt and try to perceive, try to understand, try to realize it is rough or smooth or silky or cotton based. So by touching whatever you are feeling, that is basically the textural pattern or machine learning. The engineering is required in different varieties of forms. Less ambiguity is a detecting chronic time. Obviously, you are after all dealing with the human life. So as long as humans are directly studied, definitely the errors should be zero. Ambiguity should be zero. But really, you cannot claim that zero, but as minimum as possible. Accurate healing process. Once treatment starts, then definitely area should decrease, color should slowly because the normal skin color and normal texture. That's what the is called wound management, chronic wound management. Yes, it should be less expert dependent. That means any paramedical person should do. You should divide. Medical image is basic application software which ultimately needs to be developed. Some attempt have been from our side, but it's still open problem for others. Everybody, those who are interested in individually can work on it. It should be affordable and accessible. It should not be cost. Now, software cost, if you can develop in India, the cost is. So that's not how. Accessible, that way, when visiting the clinic, doctor is not there, but somebody is there and taking the data and just taking the image, loading the computer and immediately. Even nowadays, everybody has smartphone. Use the camera. If you get that camera, you take the photograph in your smart camera and immediately you run the app. The app will tell you, yes, your degree of severity is this. So all these factors together keep the generate the necessity or need for developing technology at the end. So what are the basic tasks or fundamental tasks you had to develop and design this kind of a software or methodology for the software? The software developer is required to develop, algorithm developer required to so we are working on the algorithm development. And finally, you can pre-processing of the digital chronicle images. Why? Now our methodology I'm talking about, where 4 components are needed. First, you grab the image. So you use the Sony CyberShot camera on your mobile smart camera, whatever camera you have to use, but that should be digital cameras. At those camera, you take the photograph. At that time, you remember some light condition may be perfect, noise should not be there much, lens should be properly washed out. So altogether, visual processing. This is the for any kind of image processing task, specifically for the aeronautical images. Then from the whole image, you should get the wound region need to be segmented because your region of interest is the then on the wound region, you go for understanding extraction, feature extraction of color features and texture features. And that will help you characterize the tissue. And ultimately, you have to develop some classification algorithm to tell
Excuse me, sorry for interrupting.
Hello?
Yes, sir.
Yeah.
Sir, some issue with audio. Audio is not so clear, sir. So please explain.
Is it clear now?
Yes, yes, sir. But in between it is breaking, sir. So it is not so clear, sir. The audio is not so clear, sir. So please.
Clear now? Hello?
Yes, sir. Yes, sir.
Is it clear now? Clear now?
Yes, sir. Yes, sir. The mic is there. Mic.
Hello?
Hello, sir.
Is it clear?
Yes, yes, sir. Yes, sir. Now we can continue.
Okay. No, you always interrupt me once it's not clear. I can't understand you. From my end, with how much is job you do, but always you talk to. Let me go to it. You can see this kind of a graphical abstract. So if you can understand this graph, what has been done, just not that is, and it will help you a lot. Complete configuration, complete technology, which will emphasize on developing a comprehensive algorithmic framework based on which you can serve the purpose of chronic image analysis leading to solution data. You can see its own voice. That means a human being is standing, some ulcer is there, supposedly the leg, knee, and using this digital camera, everybody will have the camera instead of this using the smartphone camera because now it is become 16 megapixel to 45 megapixel to megapixel there. Whatever the higher resolution you can use, that's always quality image. Then this image you grab and then you through wireless or through wire transfer to the storage device, and that image is formatted basically RGB, red, green. That's basic. Now, develop simple this thing. You have to do the site because on-site visit is required to grab the image, and the image should be properly focused. Okay. Now, once this database is developed, this way thousands of people have visit either in the clinic or whatever, and then develop the database because it should be labeled by the doctor. The moment this portion is over, database is developed, then we go for a pre-processing. So pre-processing basically gives you this history, illumination correction. Light, non-uniformity background, sometimes white light, sometimes yellow light, sometimes low light, sometimes high light. So because of the effect of the light, the camera will be raw image will be different. Now we go for color transformation. Now we use a lot of beautification to our smartphones. You have the filters. So all these things basically the filter. So we apply the suitable filter. A lot of standard filters are available. Linear filter, median filter, mean filter, centroid filter, Sobel filter. You know, if it is then for the light basically illumination correction, but the noise is maybe salt and pepper. Usually salt and pepper noise are present. It means mood image, then this radial filter becomes more helpful. Now the color channel. If actually different color transformations, if you have an idea, if the color image transformation, different techniques like RGB to YCBCR, RGB to hue saturation intensity, HSI, YCBCR, you know. So basically, because the color gets getting transformed at the moment transformation is definitely some color is lost. So you have to optimize each one. And the color optimization is required with respect to maintain the contrast. So here, after this transformation through some comparative analysis, in the literature it was reported DV channel gives you the better picture. So people basically emphasizing on the quality of the raw image. So that's why it's called graphical abstract of the whole proportional image. Now, who made this segment? Once database development is done, pre-processing then done, then we are going to the image segment. So we are applying here spectral clustering, fuzzy spectral clustering, because we are understanding. See, segmentation, a lot of techniques are there. So having the visual trading approach, either dividing or marking, watershed transformation also is applied to places. It is one of the work where spectral clustering technique has been to get, because you understand the image, the neighborhood pixels have the type of values. That way you can go for a criteria definition, and the pixel sometimes becomes different. The fuzzy image and ambiguity is definitely present over there. So it defines a objective function in terms of having the degree of fuzziness. The way you understand fuzzy is clustering. So whatever segmentation based, because one segmentation will be fit to all types of answers. So for that you have to take different types of answer situations. Okay. Am I audible? Hello.
Sir, again voice is breaking, sir. It is. Can you reconnect again, sir?
Now the
voice is.
Acha, what I'm doing, I'm now removing my earphone for just talking.
Yes.
Can you hear now clearly? Is it clear? Hello.
Hello, sir. Hello. Sir, can you reconnect the
Hello.
because the voice is not so clear, sir. That's why.
Can you hear me?
Now, yes, sir, audible. But while presenting that, the audio is not clear, sir.
Can you hear me now?
Yes, sir. We can hear, sir, but not so clear, sir.
Yeah. Hello.
Hello, sir.
Can you hear me now?
Yes, sir.
Hello. Can you hear me?
Yes, sir. Hello.
Can you hear me?
Yes, sir. Hello.
Is it clear now? Clear?
Yes, sir. Yes, sir. It's clear.
Am I clear?
Yes, sir.
Anybody can hello? Am I audible properly?
Yes, sir. Now it's somewhat clear, sir.
Now it's more clear.
Uh, it's clear, sir, now.
Okay. Okay, this is visible.
Yes,
Is
sir.
it visible?
Yes, visible, sir.
Okay. Okay, if audible and visible, at least you can proceed further. So the segmentation, you can see that using the suitable algorithm, as I told you, different ulcers have different types of properties. Based on that, segmentation algorithm will work. So image analysis, you should remember one thing, that it's not any algorithm segment is fixed for everything. That way it never works. Okay, it depends on the characteristics. All right. Now, yes. Now, what do we do? Within this graph, you can see that once the full area is, once the full area is segmented, then we are interested outside of the area. We are interested within the area. And the moment within the area, you find different kinds of tissues, as I told you. Like, so these tissues are, whether it's a granulation tissue or splar tissue or necro tissue. And these are the major features which will govern the classification process. There are different classification methods are there, whether it's a classification regression trees or backpropagation neural network or random forest or Bayesian classification or support vector machines or deep learning. Different tools are there. You apply the train properly, and then you can. So there is system, basically given an wound image, system, what is the output? Computer will give you the different kinds of tissues present over there. And the percentage of tissue matters a lot. Because when it is black tissue, that means there, if the granular red tissues are there, that means blood circulation is there. But when blood circulation is there, then there is a possibility. Slowly it is getting dark. That means dead tissues are getting filtered out, and it started healing. That way we can think of. Okay. Anyway, this is one kind of some characteristics, causes, and sites in recorded wound. Pressure ulcer, PU, or extremity PU, diabetic ulcer. What are the characteristics? More area, less depth. In case of pressure ulcer, these are the standard medical practices people follow. That area is more, surface area is more, but depth is less. In case of pressure ulcer, like fragile skin, bacteria. What are the cause? Pressure, friction, shear. These causes this kind of ulcer. In which body? Ankle, heel, hip, and coccyx. These are the areas, locations of the human body where this pressure ulcer took place. Usually it affects 50 onwards people. For experiment, after more area, less depth. Same thing. There is also fragile skin, migraine, vein artery thrombosis, obesity. These are the causes. Okay. Some type of thrombosis, cerebral thrombosis happens. No. So that time blood comes out of vein or artery, and tissues become disturbed, and that creates ulcer sometimes. Okay. Sometimes it gets dissolved with the body. Body immunity power is good. Otherwise, sometimes not. And signs are at the age 42 to 60. Then it happens like this. And diabetic food is more area, the less depth. So all are mostly same type of these things. But during the healing process, the area is the clinical parameter that we take. This is a comprehensive mechanism through which you can understand what I am going to exactly talking about here. You will get better idea. The idea is that image acquisition means database development. Then you go for a pre-processing, different steps which are required. One is your collection, another is your noise reduction, then color homogenization. Color homogenization means different same persons. Suppose in the leg ulcer is there, you take at different times the photograph within a half hour time from different distances. Then due to the defocusing and distances, the image resolution, not resolution I should say, that image quality and image nature of the image will make change. That homogeneity needs to be maintained because same person, same wound. If you take same camera but take different conditions, then you may not get a clear idea. Because nowadays, because of these COVID situations, we are conducting the online classes, trainings, FDPs and all. But in case of medical area, medical domain doctors has to look at some patients. Even they can't reach to the patient because of the transport problem, because of the hospital, emergency situation. So, if you have that opportunity, a device opportunity, you can share the image to the doctor. He can see and give the advice at least. Okay. But the moment sharing the image of particular wound area, you have to remember one thing, that area should be uniform in terms of the color. So color variation, same thing, but if you vary the color, the nature and data will change. And exactly the doctor will have different kinds of impression in their mind. That's very important because doctor diagnosis not just based on the test for confirmation, but at the same time they use their own expertise, own feelings, own whatever study they have done during their MBBS, MS kind of MD kind of time. Everything together merged to a specific concrete decision. Ultimately, the decision has to be taken by the doctor at the end. Whatever software is for screening, but doctor is the final person, final authority to write the prescription. And that's how any medical software we develop, you remember, it is not a replacement of a doctor. Rather, you have to explain the doctor, look, it will be an assistive device or assistive software mechanism framework based on which doctor will be betterly evaluate. Because this will give you the percentage of tissues. And when percentage of tissue vary, then the healing process, healing nature always vary. That's the important. So in that level, color space correction, color space selection, here like DB color space we have taken from the YDB here. Then wound area segmentation. Am I audible now?
Yes, sir.
Hello.
Yes, sir.
Okay. Okay, fine. Just I'm inquiring because to ensure me that things are going on properly. Wound area segmentation. Color texture feature extraction, as I told, percentage of tissue pixels, that is the target. That's what this of a steps is required. And then finally we understand, because you might extract a lot of features, lot of parameters quantitatively. Doctor looks at 3 parameters, but 3 parameters quantitatively different. If 30 parameters will come, if 40 parameters will come, 50 parameters will circle features in the field in learning computer vision. So there, all 40 features are not equally important to differentiate different types of tissue. Okay, which pixel belongs to which class? Class we initially talk about. There are 3 classes. One class is your necrotic class, another is your calculation class, another is your SLA class. So if you output which pixel of the image should be categorized into which of any of the 3, at least partial should be classified if it is factor is there. Now, potential discriminatory feature means the features out of all features, those set of features which are very, very important in providing the clear-cut demarcation between amongst the 3 features. And that's how it is called potential identification of the potential discriminatory feature using multivariate statistics. For example, if I ask, what is the difference? Tell me one feature based on which a computer can classify an unknown object, either cat or tiger. So to differentiate between cat and tiger, which feature is required? If you tell her cat and tiger. So number of legs. This is a feature. Can you really differentiate? Because the number of legs of a cat is 4, number of legs of a tiger also 4. So you have selected a feature whose rules are same for two classes. So that is a bad feature. That means when I am talking about a feature, so I am basically talking about the good feature. So a feature will be called a good feature when you can differentiate entities. If you tell tail, that is also 1. Number of eyes, that is also 1. Number of nose, that is also a number of eyes 2. Number of this. So these features are bad features. These are individual features. But I am looking for a feature which can differentiate. This is an example I have brought us to get a very general understanding about what we mean by this potential discriminated features means good features. So if you tell that time the feature, because there is a lot of similarity between one feature, the color, the body color of the tiger is completely different from the cat, because there may be some kind of a stripes differences are there, but looking at any combination, you can realize when you go to the suppose shopping mall, see some kind of jackets, sometimes looking at a tiger jacket, because the color gives you an impression that this color exists for the tiger. So that's how you know. In this case, you have to think for certain time that yes, which feature differentiate these from the cat or cat from. Exactly in the same way, if you having that sense of that example, in this case, if you think of that once you have given the image and the wound image, within the wound area, 3 types of tissues are there and they are mixed up. So the pixel carries nature of the granulation property, or because in it is a matrix. Okay. So that's how feature become. When you have a lot of features, even potential discriminatory features are very much high and higher dimensional, then you apply multivariate statistical methods, either for fitting these things, because different statistical inferencing mechanism there, and also you can use feature comparison technique like principal component analysis. When principal component analysis you use, that means when you now have a number of features, some of them may be redundant, some of them may be interdependent. So to reduce this kind of interdependency amongst the feature, we apply some data comparison or feature comparison technique called principal component analysis, which is very, very important and mathematically very rich. Okay. Here I cannot describe mathematically, at least I use the same, it will be useful. So that is 40 features may be compressed into 10 number of features, and where all 10 are independent and they can equally describe same amount of information, maybe 2-3% difference may be there. But if that is tolerable, then you can always apply those new features obtained by principal component analysis, and you apply to the classification block classifier. So pattern classification is the major step based on which it will classify the image, whether the cell first of all picks classification problem as a part of the pattern classification problem. Then we will go for the wound classification problem. What type of wound? Is it diabetic wound, or pressure wound, or lower extremity wound, or ganglion, or skin cancer? You can think of a lot of things. For that, you have to get information. So once class is done, we will have no. Computer is not a doctor. Computer is assistive technology. Computer will help the doctor by giving this data. That's why performance to be evaluated of the system, and simultaneously doctors have to validate clinically the what computer has given is really interesting, value addition or not. Okay. So hope this methodology you have understood. Many people can start work on this based on this methodology. Methodology is one, but techniques, tools and techniques may be many more. So you have to trial and you have to apply existing things, or you are a advanced researcher, you should think of your own algorithm or mixture of the existing algorithms to come up with a good classification framework, wound classification framework, and with in some work we used Meditech wound image database. The database descriptions are there. How many different images are there that have been described? You can go through this online Meditech wound image database, and you should do through. Okay, for your reference telling you, and then in your population you can start collecting. Not at this moment when to address everything is proper, or we are back from this kind of a crisis situation to the normal situation. Everything is stabilized. You can think of having the digital smartphone. You can start developing your own database in your local, in your village, in your city, and then you can develop your own image database, maintaining some ethical issues, because you have any human data, it has to take care of the ethical issues. That's first. Segmentation, as I told you, different techniques are there for wound tissue, granulation tissue will be segmented from the background. During the healing time, new epithelial wound region and infection will also be segmented, because when the wound is detected and by putting some ointment there, or taking some oral medicines, our objective is to heal the wound area. The moment it is healing, then definitely some kind of biological changes will take place in terms of new epithelial generation, and then slowly their margin will reduce infection when infection is under control. Then over the period of time, that margin will be lesser and lesser. So there are different kinds of segmentation techniques. As I told you, pixel classification you can use Bayesian supported machine. Gaussian mixer model is part of the Bayesian is one of the cases. In improvised segmentation algorithm, unsupervised, that's what special clustering techniques we have used without understanding. Because sometimes doctors are not available to level the data, then it becomes the unsupervised data. But when unsupervised data you have, then you have to go through a clustering mechanism. And the clustering gives you a lot of information in terms of similarity of the grouping of the different tissues. So and some of the times we can't quantify, then you should go for a system development like knowledge approach. Give some kind of rules. So expert system development knowledge approach means you have to design if this then this, if this then this. That way you should define a set of rules, and that is called the knowledge. We are human beings, we are governed by the rules. We define the rules. We take the decision by the rule. That is knowledge. If now evening there is a huge wind, then I will not go outside. So everyday life, day-to-day life, we use if and then kind of a rule, and that becomes a knowledge base. This is a framework you can see. To give from the image, what are the different types of features we extract, and talks about quantity features, and this being area, being rate, and what is the by varying the different types of tissues, people can our classification technique, our classifier can tell that which type of ulcer, which is really very important, because our country mostly agricultural country. When farmers are going field, they are having during time they are most spending their major time in the field for doing all the agriculture related things, plowing to spreading the seeds, and then putting the trees on the mud butter. So the skin always are under the wet changes are there. Then because water is touching their skin for a long time, then water property gets changed, biological changes happens, and because of so many other infections, some insects are there, they may bite. So ulcer may come for any reason. That time, if you have a mechanism when they are coming back, after cleaning everything, they find some kind of person has some infection or some kind of a problem. Then scanning that and sending to the primary care center, then getting response. Okay, you have this problem. Maybe in natural language processing, you can be able to convert in the language so they can understand. There will be details. So this kind of awareness can be done through this kind of a program. By telling my mouth, awareness cannot be sometimes spreaded. Sometimes you can look at you have this one, this problem. This is the next. If you do not do it within 15 days, it will be this. Everybody will care. Right. So that is one thing. Like in TV screen nowadays, before every movie, tobacco advertisement comes, and they show some photographs. And looking at the photograph becomes very disappointed and sad. That is for the awareness, so that people, they are telling that you should not smoke or should not use tobacco. If you use the tobacco, you are going to be affected by this kind of situations. So if you can think that, okay, no problem, that's a different situation. But people are very much, in civilization, the people are very much aware and self-conscious about their health and environment. And the way this kind of awareness always helps to have a control for the country like where 130 crore people are living. Okay. When you have a feature space and different feature selection, we have to use, like the example I told you, 40 features will take in, then individual evaluate which one is found better. So suppose 25 features are found to be significant. Okay, then you go for a compression, that is called principal component analysis. Different techniques are there that are browse on the site, Google, you can find out and you can understand which technique for. But how these techniques are helpful in our this problem solving, real-time problem solving scenario, that I am just tagging and giving the idea. I hope it will definitely help you in future course of your research and evidence. Grading index, selection of the frequent multi-grade features for grading wound severity. Okay, wound classification, supervised and unsupervised techniques. As we know that Bayesian classification, Gaussian mixture model, support vector machine, neural network, deep neural network, deep learning, then the reinforcement learning, transfer learning, different learning methods can evolve that can be used. But always remember, when you are using complex algorithms, applying, then definitely the time complexity of the algorithm will be very, very high. So your system should be should have that kind of adaptivity, that kind of a configuration specification that should not hang. Okay. Rule classification using knowledge-based approach, that is called a fuzzy rule-based, because human always expresses their feelings, impression about everything. Love to express in the natural language. Okay. I love to express in Bengali. You will love to express in different regional languages. Nowadays, in from computer science point of view, you know that natural language processor has been processing algorithms people are working. So that automatic conversion, that you can see any speaker is giving lecture, suppose United Nations, a minister is doing, and others countries are listening, and they are on the phone. Basically, he is telling in suppose in Hindi, then others are listening in their corresponding language. Suppose Canadian will be their language, African in their language, Japanese in their language. English is common for others, but those people who are Chinese people will understand Chinese language. So varieties, even within our country, the speaker is telling and others, common man wants to, they do not know English and all. So in their natural mother language, they can listen. So that's how things so with that kind of advancement of technology, we can serve the purpose. Like here, the rule base, which is fuzzy. What I telling that person is telling, doctor is expressing their impression on the language. So you can put the language in terms of a if kind of rule. Their impression in the language, that means a lot of fuzzy things are there. Okay, if the wound is severe, then you do this. Or if the SLA is percentage of SLA is more than 30%, and tissue less than 10%, penetration is more than 90%, then the wound is very severe. So you can see the more than 90 means it's fuzzy, because you don't know how to and you don't have anything. No, so that's why you can make of that kind. So focus will be like this for any researcher to go ahead like this. Okay. Some of the examples I'm showing, kind of work has been done. You can see the flowchart gives you the impression about the thing instead of telling so many mathematical things that I find to explain the flowchart what has been published. given the RGB image, some color homogenization technique like and denoising process, as I told you, median filter was used to reduce the noise level, and then color conversion because of contrast. Color conversion required for optimizing the contrast. Nothing else more than that. And they did wound region segmented using spectral clustering and morphological and region extraction. So it's a teamwork. A team has been worked on that. A person has done his PhD work along with this. So this is the algorithm. I'm not going into detail. Always remember when you talk about the similarity, that means two are similar. So by similarity, you are going to construct basically the set, identifying the set of pixels which are present, and that way you can recognize it. And then different cluster points have been developed for each of the groups. There are 3 groups. If you take further, ultimately converging, you will find at the end of this is basically the Laplacian, conversion, which is required for multivariate features. This is the thing. This is features. This is the features. In the first graph, you can see it's data set. One image has been characterized, and their data cloud looks like this interdimensional framework with respect to the feature. But when you apply the similarity matrix and based spectral clustering, it gives you the features and talks about 2 sets of points. You can see it's a mixture. See, nothing can be isolated and completely. There will be overlapping, but how you can transform in such the way that the overlapping should be minimum, and that's how the construction similarity matrix is very much important. So threshold selection, in image segmentation, threshold selection always a challenging task. So as long as the world exists, threshold selection in image segmentation will remain the challenging task for all the applications. Nobody can tell this is the final threshold. So this is one thing, ground truth. So any image, computer will learn from the expert first. Human is supercomputer. It's conventional. But what I want to emphasize from the direction that once we talk about human is supercomputer, human is the ultimate authority to level. What computer is going to find out, that should be verified by the human being. So that's what, to make the similar whether computer generated, the computer generated boundary is going to be match with this image. So this is one image, this is another image. You can see there are multiple experts. Red is another one expert, yellow is another expert, and green is another. 3 experts they have marked. You have given an image of the moon to 3 doctors, and the pen of red color to one person, green to another person, and your red color to red, green, and blue, whatever. Red, yellow, and green. Okay. So different the color pens you have given and asking them, okay, mark the boundary. Then you will mark the boundary, but somewhere somewhere exactly, somewhere close, somewhere also differing. So that is the multi-level expert leveling. The human observational intra-human variation will definitely be there. Observational variation will be there. So in the segmentation result, so starting from this image and step by step going to come this image. So in this is the original scheme of the person. There are 2 areas to find this. Okay. Now these red areas I do not know. Maybe bloods have been spreaded. Maybe some other red color. So you have to be tactfully. You have to deal with this situation. This I have already described. The only thing is that instead of spectral clustering, here we use fuzzy spectral clustering. We are assuming that pixel is always ambiguous in nature, specifically when you are dealing with different situations. Here also is same thing, but we integrate this kind of a mu, which is degree of fuzziness of pixel, k pixel in the ith class, and that's how, sorry, ith pixel in the kth class, such that their sum total is going to 1. Okay. Those who know fuzzy Siemens clustering, you can easily identify how the fuzzy degree of fuzziness is getting modified through different iterations. Because any kind of k-means or fuzzy Siemens, it's an iterative clustering method. And the same clustering method, So based on that, again, same, eigenvalue, eigenvector computation will go, and finally we get a set of clusters using k-means. If you think that fuzzy Siemens and fuzzy Siemens, then you apply fuzzy Siemens clustering. every time you get the central cluster and then degree of homogeneous of clusters. How many clusters? What are the centroids of the clusters? And how many iterations you are required. So these are the different kind of the network paths. One separate address. First one is represent data points of an image. So for an image, you how to spatial, it's a spatial clustering. So spatial information is required. Spatial information is coordinate information is required. So that way, if you plot those coordinates in the two-dimensional graphs, then it looks like this. Then you go for a gray-based Fuzzy similarity matrix constructed by Laplacian model with Fuzzy spatial knowledge. Because every pixel will have its ambiguity value and the spatial information like coordinate value. Because this coordinate will give you the neighborhood information. Which similar close which is where it's changing. Like boundary condition, you know that the boundary normal wound area is ending and the normal area is starting. So in this transition, you will find out a lot of fuzzy pixels, and those pixels need to be modeled. So these are the you can see we're starting with the image and slowly all the things, because we are looking about we are interested about the boundary, then we are not interested about the color. Ultimate goal is to find out the boundary. So that's why we have got a morphological screening, morphological operator we used to find out the boundary values, but inside it's a black. We want to find out the structure. We want to find out the structure of the wound area, and that's how inside the area no color is required. Only boundary information is more important. Any structure in pattern recognition and computer vision, when you define the structure basically gives you boundary information. So structural information is embedded in the boundary information. Okay. This is performance evaluation for two different methodologies. What are the different, these are the coefficients of comparative coefficients because performance evaluation point of view, and you can find out that which technique is better. Mostly comparable, few cases, in some situations one is better, another situation one is better. This is how many pixels are misclassified. That is also important because when you talk accuracy, then definitely in this case, number of misclassified pixel helps you, to identify the amount of error. So in this case, you can see that it's a box plot. So those statistics point of view, the box plot, two algorithms are being compared, and then through comparison you can see that amount is more. In this case, your first algorithm with respect to the second one. Feature extraction basically very important. The methodology talks about the feature extraction using color and texture analysis of features, analysis of variance. Feature ranking is required using statistical information like F statistic, and then feature compression. We have discussed. These are some results. You can see the different features like mean of mean value of the necrotic tissue. So mean deviation summarized in terms of mean and standard deviation. So what you can see that all the features they are described with respect to their different kind of tissues, necrotic, granulation, and splar. They are based on a number of each category. That for one image, what is the thousands of pixels will be there, and the corresponding the value will need to be summed up so that you can get a complete picture feature-wise how they are varying from one tissue to the another tissue. So every feature, the row you can see for one image. So for one image, different features how they are varying. That happens. So the color feature statistics. That's what we do. So this way, color features can be combined accordingly. Different texture features. From computer vision point of view, the texture feature basically can quantify high level matrix, like histogram based features and all. But mathematical 19 features are there. Then 44 features are there, local binary pattern is there, fractal dimension is there. So if you add up all these, it's coming to mostly around 60, more than 60 features. More than 60 features are there. People will be confused. Doctors will be confused. It has to take you, sir. Minimize confusion. You need to go for a analysis of variance. That gives you the F statistics. When multiple features are there, two features, then these statistics. When multiple features, you should go for analysis of variance to understand the equivalence of the features for each of the classes. Comparing, because when it is a cavity wound and that is a pressure wound, same type of tissues are there, but their percentage is varying. So you have to have a, you are comparing two different, three different, four different types of wounds with three different tissue characteristics. And every tissue is characterized by more than 6 features. You understand the complexity of the problem. 180 features are available for characterizing one image. And that's why computer also will be hanged sometimes. That's why you have to apply certain technique which will optimize the number of features by minimizing redundancy and interdependency. And there are all such. This is a component analysis based graph called scree plot that gives you the information about that how many features we should consider. So instead of 60, 100 features, 180 features, this goes use the number of features as made to x-axis and eigenvalue means found, weight of the significance. Or you can tell weights. So weights are more first few features, but when it is going to 18 and then 20, it's dropped down. So you will consider 18 features in this instead of 100 features. And that's the beauty of applying the multi-dimensional thing called feature composition. Okay. Classification, as I told you, things are straightforward. You should define for every methodology. Here we have used classification regression trees. Those who have the idea of decision tree, probably what I can tell. So it's basic branching, but there are every node and one edge. So it's a classification is done starting from the root node. So selection of the root node depends on the which one is highest weightage. So weightage calculation and everything done by the Gini index. So Gini index gives you the total weight impurity, and so we define starting from there with respect to some criteria. If the value is greater than that index value, then it will be in the left side, or upper than the higher than the threshold value, then it's going to be internal. And that way, this branching has been done, and you can go for a classification of the Now, progress and neural network is a biological classification algorithm. Okay, so using neural network, you can get these images, and from these images you can see different wounds have been segmented out, and then the second row gives you the color combination. So different combinations basically gives you the different kinds of tissue characteristics. That's how computer detects. This is a human detected, this is a computer detected. So thank you very much. Okay, for listening, and hope you have understood, you have got something. Okay, if you have any questions for you, or we'll close.
So I request the participants, if you have any doubt, you may ask the question.
Or you write your question in the chat.
Sir?
I'm taking 2 minutes time. Plus, you write in the chat if you have any questions shortly.
Okay. So I request participants, if you have any doubt, you may ask the question. Is there any questions? Yes. Sir, Dr. Torse sir is asking that please highlight about the importance of ROC in this application.
ROC means receiver operating characteristic. Okay, I got the question as it is written in the chat box. So, receiver operating characteristics basically is a trade between sensitivity and specificity. In any classification algorithm, when you run, then computer gives you some pixels correctly classified and wrongly classified. So if you take a decision matrix like correctly original true and false, which pixel is true and false, but really that is a necrotic issue. The computer can classify as a necrotic or computer cannot classify as a necrotic. But my point. So once you think that computer is classifying necrotic, then it is a correct decision. So sensitivity, when computer detects the correct thing which is actually correct, that is sensitivity. Specificity is a complex false negative. Computer is, it is actually false, but computer is telling you the it is actually false, and computer also telling the false. So that way, what you can see, two things, some sensitivity and specificity decreasing. It's very difficult for a person to take a decision that which, because ideally you want both should increase, but one is decreasing, another is increasing. How much increasing, how many decreasing? So very difficult to take a decision, because at the end of the day, you have to take a decision whether this algorithm I will accept for pretty good image or not. So that time to combine these two, sensitivity and specificity. ROC basically gives you the sensitivity and specificity. Here basically in the x-axis it is represented as sensitivity, and the y-axis is represented as 1 minus specificity. So you plot, you get a curve. Total, ideally, the area under the curve is 1. So any ROC curve, area under the curve is exactly 1. That is the ideal situation. That means closing your eyes, you consider that means 100%. But the moment you find 90% still decreasing, it's up to you as a decision maker that which one, where, which up to which you will be downing. If you take, okay, my ROC area under the car, area under the ROC car, area under the ROC is suppose 80%, you are thinking, okay, more 80% I will accept. So any paper you go through when you work and compare and go for, suppose you are doing the research work and then writing a paper, then in the result and discussion section, you have to compare with the previous literature. So the moment you are going for a comparison, ROC is required. A sensitivity specificity is required first, because without sensitivity specificity you cannot compute the ROC value. So once you got the ROC, because every paper you will find out area under ROC is 0.98. That means 98%. Okay. Oh, clear to all. So
yes, sir.
ROC
Yes. Yes, sir. Thank you, sir. Thank you for clearing the doubt.
Okay, I think others, I didn't find any other question in the chat box. If there is no
Sir,
question,
I have
so
actually, sir, I have one more a small query. Initially, due to internet connectivity, I missed some slides.
okay.
So say I asked the same question. My question is, wound when we are talking, can these algorithms are equally important when we talk about surgery cut wounds?
Algorithm is technique, right? But the moment you are applying image, that it will, how the performance of the algorithm will depend on what kind of image you are training, right? If you think it's fine, it is applicable, that's why performance evaluation is there, ROC value is there. So it may be applicable. I cannot tell yes or no directly until unless it is applied. But this work have been done on the surface wounds. Obviously, that is also wounds, surgical wounds. You can apply. There also you will get the image things. But you have to do a lot of fine tuning and tuning kind of things. Okay. Thank you. You all.
Sir, hello, sir.
Yes.
Jayashree Madam is asking that please elaborate on the necessary metrics for evaluation of performance.
Decision matrix, as I told you, if you have a paper, You just draw a 2 by 2 matrix. There are 4 cells are there. So column wise you write true pixel in one column, another column you write false pixel. Now left side you write algorithm classified pixel correctly. The second row you write algorithm classified pixel incorrectly. So got the 2 matrix in 2 rows, 2 columns, right? Now what are the cells? In one cell you get pixel is true, but machine is classified also true. The first cell of the matrix. That is a correct decision. But the second cell, if you think about the 2 by 2 table, machine is classifying the pixel correctly, but actually it is a wrong cell. That is a false pixel. It's a wrong decision. Now second row, first column, cell talks about the pixel is true pixel. The machine is classified wrongly. It's a wrong decision. And the matrix 2, cell, that is the second row, second column cell, talks about the pixel is actually false pixel, wrong pixel, incorrect pixel. And machine also classifying incorrect as incorrect pixel. That's how it is. The decision. I mean, decision matrix I talk about. Now clear?
Yes. Okay, sir. Thank you. Is there any questions?
Okay, sir. Anything else? Yes.
Sir,
Okay.
can we conclude now?
Yeah, please conclude.
Okay, sir.
My lecture is finished and I have taken questions. At least what I have clarified hopefully. So now to maintain the timings, please conclude. Okay.
Okay, sir.
Good evening to all. It's a time to offer vote of thanks. On behalf of management, principal, HOD and participants, I wholeheartedly thank Dr. Chinmay Chakraborty sir, Assistant Professor, Electronics and Communication Engineering, Birla Institute of Technology, Mesra, for the topic sharing the information about telemedicine-based smart chronic imaging. Thank you so much, sir, for such an information session. Thank you once again. I sincerely thank all the participants for their active participation, and I hope that they will make best use of this FDP in their research work. On the behalf of the entire HSIT family, express deep sense of gratitude towards the management and Principal Dr. S.C. Kumte sir for esteemed institution for their kind support and encouragement towards this FDP. I take the opportunity to thank beloved HOD Dr. Ravi M. Yadhali sir for his encouragement, guidance and continuous support for successful conduction of this FDP. Thank you so much, sir. I thank my colleagues for their coordination in the process of conducting this entire FDP. Thank you, one and all.
Thank you very much.
Thank you, sir.
Okay, may I quit now?
Yes, sir, yes.
Okay, thank you. Participants, stay safe. Okay. See you in future.
Thank you, sir.
So I request the participant to fill the feedback and attendance link of this session, which will be shared very soon in the WhatsApp group. And regarding the certificates, so we'll send the e-certificates to your mail directly within 2 to 3 days. Thank you so much. Thank you.